Exomoons. They are a very rare thing in the universe. There are only two that we know of. They are extremely hard to find with the technology that we have today, because they are so far away. Even some scientists think they found some, but they were proven wrong with lots of different points of data. There are many stages you have to go through to prove that you have found an exomoon. Science is a very long topic filled with many different things. In science, there is always more ways to prove a theory than you think. It is always a struggle to prove something in science, like it is hard to prove the finding of an exomoon. But the real question is, first, we probably need to ask who discovered the first exomoon. The two people who discovered the first exomoon was Alex Treachery and David Kipping. There's not a lot of information on Alex or David. As I found, David Kipping was born in 1983. David is an astronomer and assistant professor at Columbia University, just like Alex. David went to University College London to get his academic degree, Doctor of Philosophy. He went there for 5 years. This is the University of Columbia that they worked at. They discovered the first exomoon back in 2017. They were looking at exoplanet Kepler 1625b-I. They discovered that there was an exomoon orbiting the exoplanet. It took them 1 year to confirm it was an exomoon and publish their findings. In 2019, the research was reanalyzed, but there was nothing to confirm it was not real. They called the exomoon Kepler 125b-I. I know, not that exciting for the name of the first exomoon, but hey, that's what they named it. Can't change it now. They used two different telescopes. The first telescope that was used was the Kepler Space Telescope. The second telescope was the Hubble Space Telescope. The only problem with the telescope was the telescope turned every 3 months, so the pixels were never in the same location they were in. Now, before talking about how they discovered by astronauts, let's talk about how light intensity from a star decreases when a moon is in front of it. When a moon passes a star, it is blocked out by the moon, making the light from the star decrease in intensity. That is how some planets and moons are found in our universe. The bigger the object, the more of the star is blocked out for us. To know if it is a planet or a moon, astronomers have to see if it has a routine. Then there is other data that needs to be run through to confirm it is actually something. If the other data does not add up, then it is some random rocks going through the star's vision for us. That is one of the ways things like exomoons are falsely discovered and discovered. Sometimes it is just the telescope acting up, but it's only sometimes. Sometimes it is just the astronaut making false planets and moons, because that's what they want to discover stuff. Maybe it's just a theory. Now, how do exomoons get found by astronomers? The first discovery happened in Coal World Labs. The first evidence that shows there was an exomoon is the timing offset. The transit never occurred every orbital period. It changed every 20 minutes. Sometimes arriving earlier, sometimes occurring late than expected. This is known as TTV, or transit timing variation. This is a cause of a exomoon by the exomoon's gravitational pull on the planet, which does not show enough data because it, it can be other planets causing the effects, as shown here. There was a second dip in starlight from the data consisting of the exomoon passing in front of the star, showing a second decrease in starlight. It can't be proven yet with the data because there is only one good transit of the moon. It cannot be proven that the telescope did not malfunction. But the data came from the Hubble Space Telescope that only had 40 hours of data, and the telescope they used is known to malfunction. There was never a moon or exomoon that is ever thought to be that big. So it might look like exomoons or moons like that can't be real. But they look for moons that big and further away from us by the stars. And there was moons that are big out there, so there's still hope. So they made a survey that had to meet the criteria for it to be an exomoon. They had to have an orbit wider than the Earth's, they had to have at least half the size of Jupiter, and they had to have at least 2 recording transits by the Kepler Space Telescope. The only problem with the transit is it shows all kinds of extra wiggles from the changes of the telescope and the intrinsic variability of the stars. These astronomers have to find a way to correct those effects. It's called the method marginalizing detrending. Many different astronomers made different approaches to fix the problem. So they used all their data to correct the error, and they made a vote on which one was correct. Next, they went through the corrected light curves and fit different physical models to the data set. He asked, how well does the planet itself explain the data against a planet with the moon? For it to be a exomoon, it has to be 10 times more likely that the planet with a moon. This is known as the Bayes factor. The reason why it has to be so high is because it would be considered strong evidence in the model selection studies. Then it has to fit a circular orbit for a planet because high eccentric orbits are thought to be unstable location for exomoons. Sometimes when a planet passes through a star, it goes by a star spot, making it look like there's a moon there. For one of the ways to confirm a exomoon is looking at the noise property of the transit. Astronomers also look at the timing to see if the timing is off by too much. Injection recovery is also used. Injection recovery is when injected a known truth like the planet and then push it through the entire pipeline discussing the planet has a exomoon. This is often would be conclude there is a exomoon. The resulting number is the false positive probability, or FPP. It is the probability that the astronomer are wrong. This is the recovery process. For 3 decades, thousands of planets have been discovered and more in the future. There are only two exomoons ever discovered throughout history: Kepler 1625b-I and Kepler 1708b-I.
How much downloaded?
I'm going to go over what I went over so you won't forget. So, exomoons are extremely rare. There are only two that we know of, but there are more to find out there. Our technology limits how far we can get into our universe, but we can use stars to new planets and moons. We would have never found thousands of planets and moons and other things in our universe without technology now. When something is thought to be discovered, it might just be a star spot or the telescope malfunctioning. So astronomers can never be truly sure, but you have to go through many different sets of data to be sure. The astronomers who discovered the first exomoon were Alex Treachery and David Kipping. They both worked at the University of Columbia. David went to the University of College London for 5 years to get his Doctor of Philosophy. They discovered the first exomoon back in 2017. They officially named it Kepler 1625b-I. It took them 1 year to confirm it was an exomoon and publish their findings. In 2019, the exomoon was analyzed, but they found nothing to show that the Kepler 1625b-I was not a exomoon. There are only two telescopes that were used to locate exomoons. One of them was Kepler Space Telescope, and the other was the Hubble Space Telescope. The problem with the Hubble Space Telescope was that it turned every 3 months, so some was at one point on the telescope was relocated to another position. When a planet or moon goes in front of a star, the light intensity decreases because of the blocked out part of the star. The larger the object is, the more of the star is blocked out. To know it was not the telescope messing up or a star spot, it must have to have a routine. If there is a routine, it might be a planet or moon moving in front of the star. Sometimes it goes unnoticed because a false planet or moon. The first discovery was at Cool World Labs. The first evidence was a timing offset in its rotation around the star. The timing offset was 20 minutes early and 20 minutes late. This is known as TTV, transit timing variation. It is also caused by Exomoon's gravitational pull of its planet. Starlight research is also used. It can be seen by dips by the moon's passing from the star. At least two transits have to be covered for it to be true. It is not only one, it would be false, like the transit recovered from the space telescope back in, because the telescope is known to malfunction.